We're going to start learning direct variation today. Direct variation means that you're going to put your equations into the y equals ax format. You can only have it that way. This shows you that the y-intercept is always going to be 0. As you can see, there's no plus b. The slope is also known as a constant of variation, which we're going to refer to as a. So let's start with 4x plus 2y equals 0 and negative 2x plus y equals 3. As you can see, they're not in the direct variation format. They're not in the y equals ax. All right, guys, ignore my spelling error, which you probably didn't notice until I mentioned it. It's not isolate-y, it's isolate, all right? So isolate y. How are we going to isolate y? Let's get x on the other side. Subtract 4x, and then y is almost isolated. We just have to divide by 2. So we get y equals negative 2x. That is our direct variation equation. As you can see, there's no plus b, minus b, nothing. That b is 0, which is why it's not there, which allows it to be written as direct variation. As you see for this next one, there's a plus 3. That's not okay. That plus 3 is not going to let you make this a direct variation. Because as you'll see later on when we start to graph direct variations, the whole point is that the line that we're going to draw goes straight through 0. Having a y-intercept won't let you graph it so that it goes through the origin, goes through 0, 0. This would go through 0, 3, right? It would be on the y-axis at the 3. So we can't have anything that has a plus or minus in an equation for it to be a direct variation. Let's try another one. We have 3x plus 4y equals 0. As you guys see, flip through your pages. This is most likely going to be further along the line. I'm going to just go through a couple problems with you. For this direct variation, you get y equals negative 3 over 4x. Negative 3 over 4 is the constant of variation. It's also known as a constant of proportionality. Again, it's the same thing as slope. We're just using a different variable, a. As you can see for this one, you get a plus 1, meaning it's not a direct variation because that y-intercept is going to be something other than 0. When you graph a line, just like we just did in red, this goes straight through the origin, which makes it a direct variation. Remember, these are all types of linear equation. All we're doing is going in a little bit lower into a section of different kinds of linear equations, right? These are called direct variations because they go through the origin. What's in blue doesn't go through the origin. That y-intercept isn't 0, meaning it is not identified as a direct variation. Sometimes we'll have a chart that's written like this, as a table. It'll show you that y equals 2x. In the other chart, y equals 2x plus 5. Sometimes we can identify just from the equation that, you know what, that is a direct variation because it doesn't say plus or minus anything. If we put 0 in for x, we're going to get 0 for y, which gives us 0, 0. Whereas this next one in blue, if you have y equals 2x plus 5, you see that plus 5 and you're like, oh, nope, definitely not a direct variation. As you can see, the 0, when you input 0 in for x, you're going to get 5. That would give you 0, 5. But there are going to be other times where you get a chart and the equation is not given to you at all. But we can still check this because you're given the x and you're given the y. Remember our original equation, y equals ax? Let's change it so we get a equals. Divide both sides by x, we get a equals y over x. When we take the chart and put y over x, y over x, y over x every single time and reduce it, we see that the constant of variation is the same for all of them. We get 2 over 1, meaning yes, this table will give us a direct variation when we go to graph it if it ever wants us to, because you know what? We still get the same slope every single time. The a is consistent, right? The a is constant, hence constant of variation, constant of proportionality. It is proportionate. Let's try another one, right? You can get 3, 6, 9, you get 0, 3, 6. Let's do y over x. You get 0 over 3, 3 over 6, 6 over 9. But these all reduce to different types of fractions. The a, the slope, is not constant, meaning it is not a direct variation because we can see it's not going to be consistent. You always do y over x, not x over y over x. Other times we might get a number for 15, a number for x and a number for y. Input that into a equals y over x. You get a equals negative 5 over 15. Remember, always simplify. You get a equals negative 1/3. Now remember, this is your constant of variation. You still need to input that into the original formula, which is y equals ax. We have our a, which is negative 1/3. Once we have that a, we can write a direct variation equation. You're just looking for that one number. It could be a fraction, it could be an integer, right? You have various options. Let's try another. You have x equals negative 18 and y equals negative 4. Remember, it's y over x. Y over x. So you get negative 4 over negative 18. When we simplify that and then divide by 2, well, negative 2, you're going to get 2 over 9. Let's put that into our direct variation equation. Again, y equals ax. So we get y equals 2/9 x as our final equation. Now, on page 6 in your packet, if you get a graph, if it gives you a direct variation equation, it's literally telling you that graph is a that line is a direct variation equation. Let's graph it. Find 0, use the slope, which in this case is negative 5, to draw a point and draw a line. Remember, keep in mind, a direct variation is a line with a slope of a and a y-intercept of 0. The next one, again, it tells us that y equals 3/5 x. Our slope is 3/5. Our direct variation is 3/5. Put a point on 0, 0, use 3/5 and draw that slope. If you're given a graph, you can also take the direct variation from it. Right? You have 0, 0. You're given negative 4, negative 3. That slope right there, you can tell what it's going to be and you can input it just in for the slope. Or use that negative 4, negative 3. Input it into a formula. You can solve it this way, as I just showed you in the video, or the original way that I just showed you before. X equals negative 4, y equals negative 3. Y over x. You get 3/4. There are a couple of different ways to solve it. Sometimes you could read the graph. Sometimes you could input it into y equals ax and solve from there. Rearrange it and isolate a. Other times, you can literally put a equals y over x and put it over. This way, now you'll be able to solve for anything. Like in this case, x equals 80, solve for it. You find out that y equals 60 because you substituted the information you have. So now you try and check your answer with the rest of this video. Remember, this is page 7 in our packet. If you have any questions, ask each other, use each other. Check your answers as you go. The answers will be on Google Classroom. The answers will be uploaded for the entire packet so you can check them.